Alright, hello guys, it's Chris Carlson, and we're going to go over the atom very shortly, and then just like this super basics of chemistry, which are just to basically to help you with your calculations and whatnot. So actually below this video you're going to find another video about the history of chemistry, which is actually very informative, and also some information about the periodic table that I typed up for y'all. That just lends itself better to that format rather than having a video of it. So let's start off with the basics of chemistry, which would be one of the most basic would be the scientific notation. So I'll write up 2 examples for y'all. Alright, so as you can see here, we have, what is that, 100 million, which you can see is takes some time to write. But, you know, scientists have their quick little trick that you can do. All you have to do is count up the zeros that are after this, after the 1. So it'd be 1, 2, 3, 4, 5, 6, 7, and 8. So then you can rewrite this as 1.00 times 10 to the 8th. And then over here we have like the same thing at the top, but instead of going to the left, it goes to the right. So you can write this as 1.00 times 10 to the, but we have to, before we can find this, you have to count up the zeros, right? So you count how many it takes to get the 1 past the decimal place. So it goes 1, 2, 3, 4, 5, and 6. But since we're not going to the left, we're actually going to the right. You have to make this a negative. Now that was just a really quick example, but I'm sure y'all get the gist of it, because I know you're all smart. So next we're going to talk about dimensional analysis, and we're just going to do another quick little example of it. So dimensional analysis is basically just a way to convert units to the other unit, to convert units without and just keeping it nice and tidy. So we're going to start off by converting 3 yards to inches. So we're going to start off by writing 3 yards right here, and then next we have to convert it to feet, and we know that in every yard there's 3 feet, so we can put a 3 feet here. And then to cancel out the yards, we divide it by 1 yard. And then to convert it to inches, we know that there is 12 inches in 1 foot. So then we can see that the yards cancel off, and then the feet cancel out. And then all you have to do is multiply these 3 numbers, which is 3 times 3 is 9, and 9 times 12 is, let's go the long way, right? 9 here, 9 times 2 is 18, 1 here, 9 times 1 plus the other one is 10. So we see that 3 yards equals 108 inches. See? So as you can see there, we kept everything nice and tidy, kept track of our units. Now that was just a super basic example, but you're definitely going to be using that one quite a bit, especially when you get into stoichiometry and all that. Alright, next we're going to talk about molar mass, but first, what is a mole? Now, technically speaking, mole is a unit of measurement used in chemistry to express amounts of a substance defined as the amount of any substance that contains as many elementary entities as there are atoms in 12 grams of pure carbon-12. Now, what does that all mean? That basically means that 1 mole of a substance is equal to the same amount of atoms in a 12-gram sample of carbon-12. Now that actually can translate to Avogadro's number, which is 6.022 times 10 to the 23rd. So you can see that's a very big number, because this 23 is not a negative, because we just learned our scientific notation, right? Now, let's learn a little bit. Let's do a quick little molar mass. Molar mass is basically it's the grams per mole of a substance. So if you look at the periodic table, the masses of the elements are actually their molar masses. So when you look at, let's take oxygen as an example, O2, because it's a diatomic molecule. Its molar mass, if there was molar mass, is 16. So then, but since it's only diatomic, there obviously has to be 2 of them, so it's 32. So there's 32 grams per mole of oxygen. So in every mole, there's 32 grams. And that's basically what molar mass is. So basically, all you do is you take the chemical formula, so CO2, and you'd add up these masses. Carbon's 12.01 plus 16 plus the other 16. Add those up, and you get its molar mass. So that's how it works for all of them. So thanks for watching this. Probably really boring. Probably was really boring. But you know, it'll get more interesting later on. Alright, thanks.